This is the second assignment on bearing that I handed out in class, and I'm going to work these problems. You know, if you don't need a particular problem, you can fast forward to the one you do need. The key to this is being able to draw the picture, and then once having the picture, developing the relationship so that you can solve for the missing part. So everything is in relation to the north. On this particular one, it says that a ship traveled 70 kilometers on a bearing of 27 degrees. So once again, you're going to draw the north. This is from the north. And the ship travels 70 kilometers, and I'm just estimating, right? And so this is a bearing of 27 degrees from the north, 70 kilometers. And then it changes direction. So the north-south is going to travel with it here. I'm going to go ahead and do the north here in this particular problem. And then it turns on a bearing of 147. Well, from the north, this is 90. And 147 is somewhere like this. And it's going to travel for 180 kilometers. And this is where the ship ends up. Connect the dots. Now, I'm estimating. I don't really know where this ship is. I didn't measure anything. Nothing's really in proportion, so I don't really know. But it's about here. But I can't say it's horizontal to the ship. I can't say anything like that about where the ship is. I can only deal with what I have up here. 27 degrees here, and then I know that this is 147 degrees to here is 147 degrees, which would leave at 180. This would be 33 right here. Okay, so I'm using the geometry relationships to find just this piece right here. The other thing I can find is that this north-south line and this north-south line is always going to be parallel, always. So if this is the transversal, and this is 27 degrees, so is this one. And together, I have 60 degrees. Okay, so now I have a side, an angle in between, and a side. And what they want is to find, this is the starting point, and this is the ending, and so this is the distance. So I'm going to use the law of cosines. To find D. And D is 157.16 kilometers. Two lighthouses are located on a north-south line. Well, what's the best way to start this? Make a north-south line. So here's a north-south line. Here's north and south. And on it are two lighthouses. One is A and one is B. It says from lighthouse A, the bearing of a ship so many meters away is 129 degrees and 43 minutes from the north. So here I am at A. This is 90, so 129 will be this way. Okay, and I don't know how far I want to do that yet. I may have to erase, so I just drew it out there. But this, from here to here, this is the given information, is 129 degrees, 43 minutes. Don't change it to decimal, because you're going to have to round, leave it in exact form. And this is 3742 meters. All right, from B, the bearing of the ship is 39, so to about here. Okay, so this is the ship right here. And what I'm going to do is just erase the excess line here. Okay, and then it said, this was the given information. It says this actually is 3943. And it's inside the triangle, which is kind of nice. So I already have this angle inside the triangle. I can find this angle right here by taking 180 minus 129 degrees and 43 minutes. Okay, I'm going to borrow. So this is 79. If I borrow, remember that there's 60, not 100. And this is going to leave me 17 minutes. And this will be 50 degrees, right? So that's what this is right here, 50 degrees and 17 minutes. Now, if I want to find this angle right here, this angle, all I have to do is add the two angles that I already have, and I get, this comes out to be 60, right? So then that would just be one more over here. 10, this would be 90. So this angle, even though I didn't draw it that way, is a right angle. Okay, fine. So I could write it like that, draw a right angle. My diagram wasn't very perfect, was it? And that points out what I said on the previous problem. I put the ship out here somewhere. I didn't really know where it was. Now that I know that that's a 90-degree angle, I probably would have drawn that differently, right? This would have come out further. This would probably be a little shorter and maybe a little higher up. Doesn't matter. So I can do this one of two ways. I can use the law of sines, because I can use law of sines on any triangle. And so that means I would have the sine of 39 degrees, 43 minutes over 3742 meters is equal to, oh, holy crap, what am I trying to find? Well, the distance between the lighthouses. So I need to find this. So this would be the sine of 90 over d. And I could do that and find d. Another way to do it is just use the right triangle, so ka to a, right? So this is 90, this is the hypotenuse, d is the hypotenuse, and I have something here's opposite, so I could have used the sine of 39 degrees and 43 minutes is equal to opposite over hypotenuse and solve it that way. So either way, I got 5856.1 meters on this problem. Okay, problem 3. It says radio direction finders are set up at points A and B, which are 2 miles apart on an east-west line. So I'm going to draw myself an east-west line. Tried to draw myself an east-west line. All right, east-west line, right? So this is west and this is east. And I have radio transmitters set up at A. This is A, and this is B. Okay, 2 miles apart. And that's so far, first one. From A, it is found that the bearing of the signal from a radio transmitter is north 36 degrees 20 minutes east, while from B, the bearing is 40 northwest. Find the transmitter from B. All right, so here's my transmitter somewhere out here. I don't know where that is. I'm just putting it out there. But I do know that it is north, this is north, and east, 3620. So I do this. And this angle right here is from the north, 36 degrees 20 minutes. From B, this is north, goes this way. The angle is to the west, 36, nope, not 36, 43, right, 43, 40. Okay, find the distance of the transmitter, that's T, from B, so I need to find this distance right here, that side. So what I need are these two angles right here, right? And I know that north to east is a 90-degree angle. Same here, 90-degree angle. So I would subtract. So I would have 90 minus 3620. So 5340. And over here I would have 90 minus 4340. And you may be able to do this in your head. That's awesome. But maybe not. 4620. Okay, and so now I just use the law of sines to set it up to find x. So I would have the sine of 53 degrees and 40 minutes over x is equal to the sine of over 2 miles. So I need to know what this angle is. This one right here. Okay, so 5340 and 4620, that's 60, add 1, 0, that's 100. So this is just 80, right? 80 degrees. So leave it in exact form. Okay, And the answer is 1.64 miles. Problem 4. Radar stations A and B are on an east-west line 3.7 miles apart. East-west line, this way, A and B, and they are 3.7 miles apart. A detects a plane at C on a bearing of 61 degrees. So there's a plane at C on a bearing of 61 degrees at A. So here's north, 61 degrees from here to here, 61 degrees, okay. Station B detects the plane, here's the north-south line, at a bearing of 321 degrees. All right, so I know all the way around is 360. So 360 minus 321 is 39 degrees. So I know that here to here is going to be 39 degrees. Because all the way around the other way, all the way around this way, is 321 degrees. Okay? So 39 I know has to be there. Well, if this right here is a east-west line and this is north, then I know this whole angle right here has to be 90. So I can find this angle, same difference here, I can find this angle. So now I have two angles in the triangle and one given side. What are you asked to find? You're asked to find the distance from A to C. So that's going to be your variable x. So use your law of sines to set this up. I have the sine of, what did we decide this was? 51. And we decided this was 29. Okay, so the sine of 51 degrees over x is the sine of something over 3.7. So I have 180 minus 80. That's what it looks like to me. So 100. So the sine of 100 degrees. And x will be 2.92 miles. Okay. Okay, number 24. An airplane leaves an airport and travels due east for 255 miles. It then heads due south for 330 miles. From its current position, along what heading should it travel to reach the airport, and how far is it? Okay, so I have an airport, and my plane, here's my airport, is going to travel due east for 255 miles. Okay, this is east. Okay, due east. And then it says it heads due south, which amuses me greatly because why? That would mean that that plane had to go, and turn like a right angle all the way down. But we're going to go with it. Okay, so this is south, right, for 330 miles. All right, so this is its current position right here. This is where the plane is. And A was what? A is the airport. This is going to be really helpful for the bearing. All right, it wants to know what heading should it travel from here to here. All right, and then how far. So it says, how far is it? So that's my distance. That's what I need to find. Okay, so if this is going to be a right angle, right, you agree? And so you can use the Pythagorean theorem to find the distance. That's real easy. Okay, and then the bearing then is, if I'm going from here to here, then this would be in a northwest position, right? That's one way that I could do it. It would go north and west. So I'm going to go ahead and write that. It's going to be north and west, and I don't know why I wrote east. Hold on. West. Okay, and then I need to know the degrees from north, right? So what I need is this angle right here. Regardless, I need that angle. So it's a right triangle, so I can find that angle fairly simply. I think on my paper I decided to use tangent since I already knew what these others were, so 255 over 330, and then whatever angle I got there, that's drawn from the north, so I can just put that angle in there. This is theta. Okay, now if I did the other way, then what I would do is I would do 360 minus what I got from theta, and that would also be a bearing. Okay, and that's the heading that I would take. So you're going to get one of two answers on that. Okay, so attempt this. This will give you a hint. Figure out what the answers are, and I'll give the answers in class. Okay, number 25. Two small boats leave an island at the same time. Boat A travels due north for 21 miles. All right, so here's my island. Here's my little island, right? Island. And it travels north, due north, for 21 miles. Okay, this is boat A. Now, boat B leaves the same island and travels due west for 18 miles. Okay. It says, how far apart are the boats? And what is the bearing of boat A from boat B? And the bearing from B to A. So you're going to find both of them. So you're going to go, how do I get from A to B, and how do I get from B to A? So the first thing here, since these are due, this is just a right triangle. So to find the distance, you're just going to use the Pythagorean theorem. So D is equal to the square root of 21 squared plus 18 squared. That's how far the boats are. That's easy. And if you were doing this on a test, right, then that'd be easy, and you'd have it. It'd be perfect. Okay, so then, now, what I need are angles. So I need angle A, I need this theta, and then I'll just call angle B beta, or you could call them angle A and angle B, but I need those angles. Okay, because that's going to help me find the bearing. Now, you have a choice on bearing. You can either use degrees, from north, or you can use the north and west. Sometimes this is easier. So, for instance, from A to B, if I need to know getting from A to B, I'm going to need theta, right? And to find theta, I can find the tangent of theta is 18 over 21, right? And that gives me theta. So that would be whatever theta is going to be south and west, whatever theta is. Another way I could do that is I could take theta plus 180, and that would give me the same bearing just from the north. Okay, from B to A, okay, that's going to be beta. And beta, I can be found, that would be the tangent of beta is equal to 21 over 18, flipped around, right? Or couldn't I have just done 90 minus theta, whatever I get for theta? Sure. Okay, so this is going to be going a different way. This is going to be going north and east. North and east, from B to A. So I'm going to say north, and then whatever I get for beta, and then east. And then what I'm going to do here, to find it the other way, this is, change colors, this is north, right? And if this is beta, then this would be the bearing. So if I just do the regular angle, I would take 90 minus beta, and that would give me my other course. So that should get you started, but here's your picture, and then from that you should be able to do this problem. Okay, this one is a challenge. This one is the challenge problem because this doesn't look like, this one is a little more complicated. Okay, so a plane leaves an airport and travels 2 hours along a heading of 120 at 175 miles per hour. Okay, so what they did not give us here is how far did it travel. So let's look here. I've got north, right, here's north. I want 120. Goes this way. So I'm going to go this direction, right? This is 120. And I'm going to go along a heading of 120 for 2 hours at 170 miles per hour. Once again, we're using rate times time equals distance. From that, you know, if you're given a rate and a time, you know how far you're going to go. So it goes to here. It then turns onto heading 30. So I'm going to draw in my north again and the east. And 30 is going to be this way. And it's going to travel, this is 30 right here, for 2.5 hours at 200 miles per hour. And that's my distance. How far is the airport? This is the airport. And this is where the plane ends up, right? And draw it like that. Okay, so on my paper, I used a straight edge. I'm not going to lie. And I don't have a straight edge on here, so this is kind of hard to do. But you can begin to see, what do I need to find? I need to know how far from the airport is it here, and what is its heading to the airport. So the heading is going to be from the plane to the airport. From the plane to the airport. So I need to be able to find then, I need to be able to find where it is here. Where it is here. So as you can see, I have kind of drawn in the X and Y. So I can begin to see some of the angles and what they look like. Okay? So I need to find D, so I need this angle right here. I need this angle. So I'm looking for here's a horizontal, here's a line straight up and down, here's a straight up and down line, here's a transversal. Okay? So I do know, and here's one, right? I do know that this angle right here is 90 minus 120, which is 30 degrees. So if that's 30 degrees, then one of these also has to be 30 degrees right here. Well, this is 30. This is 30. That's 90. This is 30. This is 30 right here. So this has to be 60. So this angle right here has got to be 90. So you have a right angle. All right. Here, I know that this is, if this is 30, so is this one. Right? But I don't know what this is. I don't know what that angle is. And I really don't know what this angle is either. I know this angle over here. I don't really know what that angle is either. I know this side, and this side, so I can find D. So I'm going to use the law of cosines to find D. I'll start with that. So D squared is equal to whatever this is. Oh, hold on. I don't have to use the law of cosines. What can I use? I can use SOHCAHTOA. I can use Pythagorean theorem because this is a right angle. So once again, D is going to equal the square root of whatever 175 times 2 squared is, plus 2.5 times 200 squared is, and that'll give me the length, the distance between the plane and the airport. Okay, so what I need is I need to find X. I need that angle. And I should be able to find the angle if I know what the sides are, right? So I can find the tangent of x is opposite. Notice I didn't even work it out on the calculator. I'm just writing it. Okay, and so x then is going to give me this angle right here. But what I need is, to get the bearing, is I need this angle. So it's going south and west, and so I need an angle here. So once I find out what x is, if I take x plus 30 and put it in here, I should have the bearing. So try that out, see what you get, and that's it.